Alright, first up we're going to graph some lines. But before we graph a line, we have to realize that we've got a linear equation, 4x plus 3y equals 24. And that there are infinite solutions to that. Every point on the line, when we draw a line, every point on that line is a solution. And so let's say if x equals 1, 4 times 1 plus 3y equals 24. So 4 plus 3y equals 24. If you subtract 4 from both of those sides, 3y is equal to 20. And so y is equal to 20 thirds if you divide by 3. So a point 1 20 thirds, or if you want to prefer the repeated decimal there, you could use that. Or let's say if y is 2, we could solve for x. So 4x plus 3 times 2, so 4x plus 6 equals 24. So 4x equals, subtract 6, you get 18. And so then x is 18 divided by 4. And so there's another point on the graph. You could do this forever because there are an infinite amount of points on the graph. So, graphing lines, there's a couple different ways we can do it. Easiest way that we remember is this is in slope-intercept form. Slope-intercept form because it has the slope first and then the intercept. Easiest way to graph this is graph the starting point, 1, 2, 3, 4, 5, 6, 7. Remember that it's the y-intercept because y equals, when x equals 0, you get the y-intercept. So, and then this slope is negative 1x. So the slope is negative 1, so you go down 1 for each one you go across. Down 1 over 1. And you plot the slope, whatever it is. So there's your line. And we'll label that with an A. Alright, so this next one is in standard form. Y minus 2x equals 6. So two ways you can do this. You can either add the 2x over and it's in slope-intercept form, and that's what most of you prefer. Sorry, we'll plot this as being 0, 7 and 7, 0 because we said label all intercepts here. And so 2x plus 6 equals 0. Sorry, equals y. So the 6, and you go up 2 over 1, or go backwards, down 2 and to the left 1. Remember, we always go left to right, but in this case, we ran out of room, and so I'm going to go just backwards. Down 2 over 1, repeatedly. And so this is 0, 6, and negative 3, comma 0. Another way you can do this is looking at x and y intercepts. I call it the cover-up method. If y equals 0, you're down here. The y values are 0 down here. And so if you plug up the y and make it 0, the x-intercept is negative 2x equals 6. So then x equals negative 3. And we got it. Or the y-intercept, if you cover up the negative 2x, because x equals 0, cancels that out, then you get y minus 0 equals 6. So y equals 6. And that's what we got as well. The next two are horizontal and vertical, and we get those switched up a lot. So be very careful with these. Y equals negative 2. So y, all the y values are negative 2. and that is this horizontal line. So this was A, this was B, this is C. And it has a x-intercept of 0, -2. And if that's horizontal, this is going to be vertical. I'm just going to jump ahead on this one. Remember, 3/2 is 1 1/2, so this is D. 3/2, 0 is the x-intercept on that. So what does it mean exactly to be linear? Think in terms of it has to look like y equals mx plus b, or ax plus by, we use capitals for that one, equals c. Either one of those forms. 1x, 1y raised, what I mean by that is 1x and 1y raised to first power. And not multiplied together. That's not allowed. So essentially, it's linear, meaning it looks like a line, not like anything else. So other functions you've learned about, y equals x squared is not linear. Y equals x squared, 0 squared is 0, 1 squared is 1, -1 squared, 2 squared is 1, 2, 3, 4, and so on. So that's a parabola. We call that a quadratic function. And another nonlinear, when you did y equals, say, 2 to the x. To the x power, that's exponential. X is in the exponent in the exponential function. So 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power, if I'm just plugging in x's, 2 to the second power is 4. 2 to the third power is 4, 5, 6, 7, 8. And then if we go backwards, we're dividing by 2, and you get this asymptote, as we call it. And we'll talk about that later. But some examples of nonlinear equations. This is the essential that you have to remember. You've got the slope-intercept form or the standard form. Be able to graph from both. Be able to graph horizontal lines and vertical lines.